So working with what we call right triangle trig. So if we're given a right triangle, so in a right triangle here, this is going to be the right angle. Usually we have A, B, C usually denotes the right angle. But notice opposite angle A is going to be side A, which is going to be a little a. Opposite angle C is going to be little c or side C. Opposite angle B is going to be little b, which we use to denote side B. So notice how in our drawing here, opposite angle A is side A, opposite angle B is side B, opposite angle C is side C. So that's what the opposite is going to be directly across there from it. So in our question, it says solve the triangle ABC if A is 25.2 and C is 4.1. So what they gave us so far is A is 25.2, so 25.2, and C is going to be this 4.1 millimeters. So to find angle B, what we pick up on is in a triangle, A plus B plus C has to equal 180 degrees. Well, if C is equal to 90, if A plus B, if C is equal to 90, 180 minus 90 would be 90. So what we pick up on is in a right triangle, these two acute angles have to add up to 90. So if I know one of the angles, to find the missing angle, all I really got to do is go 90 minus A in this situation. So to find angle B, all we really got to do is go 90 minus, because these two angles have to add up to 90. So if I go 90 minus 25.2, that's going to give me then 64.8. So angle B is going to be then this 64.8. So from there, we've found the three angles now. So we know angle C is 90, angle A is 25.2, angle B 64.8. But we still need to find side A, side B, and side C. Well, actually, side C is 4.1. So really, all that's left to find then is side A and side B. So then that would be all that's left to find is A and B because they gave us the other information. So to find side A, what we can do is figure out using our trig functions, so, ka, toa, we can try to figure out which one of these trig functions would be the easiest one to make this work. Well, to find A, notice how A is opposite angle A. So if I'm using angle A, side A is opposite of angle A. And notice that C is the only other piece of information we know. So notice that side A becomes the opposite side. The C, the 4.1, is the hypotenuse. So to me, if I'm looking for A, I have to use opposite over hypotenuse. Well, that's the sine function. So if I take the sine of 25.2 degrees, that's got to equal the opposite side, which is A, over C, which is 4.1. Now, to solve for A, I like to treat this as a proportion. I like to put this over 1 and solve it by cross multiplying. So 1 times A is A, and then 4.1 times the sine of 25.2 degrees. If I do that math there, it'll give me the value of A. So if I go 4.1 times the sine of 25.2 and hit enter, I get this answer. But one thing I need to double check is make sure the mode of my calculator was in degrees. Notice that my mode was not in degrees, so I need to change it back to degrees. So if I quit that, if I come up here and highlight this, bring it down, hit it again, notice that I do get a different answer. because it's in the wrong mode. So make sure you're in degree mode here, and that would kick out then this 1.7, and we're going to round to the thousandths place. So uh, that's going to be 1.746. So 1.746 millimeters. And then if we want to find angle B, if we're still using angle A, notice that angle B is the adjacent, and C was the 4.1. So we want to use the number that's not rounded. Notice how A was, side A we had a round. So let's use C so we're not rounding anything. So if we use adjacent over the hypotenuse, notice this actually turns into the cosine function. So we said this was what? 1.746. So if I want to find angle B, I actually can use, I'm sorry, side B, we can use the cosine function of 25.2, and that's going to equal the adjacent, which is the letter B, over the hypotenuse, which is the 4.1. So again, way we can solve this is cross multiply. We can write this as a proportion by putting this over 1. So 1 times B is B, and then all I have to do is figure out what 4.1 times the cosine of 25.2 degrees is. I know I'm in the correct mode now, so 4.1 times the cosine of 25.2, and it gives me then 3.7. So B is approximately 3.709. That looks like it's going to turn into 710 because this 9 is going to have to move up to a 10. So 3.710 if I round that to the thousandths place. So 3.170 millimeters would be side B. Now remember, the hypotenuse has got to be the longest side, so neither side A or side B can be bigger than 4.1. So we should have that going on here. Now, notice that this drawing is not to scale very well because notice that side A looks longer than side B, but notice that angle B is the bigger angle. If angle B is the bigger angle, then side B's got to be the bigger side. So side A should be the smaller side. So this drawing is not really drawn very well. So notice that B is the bigger side, C is the smaller side. So this drawing isn't very accurate because 64.8 degrees creates a longer side. So those are some observations we can make. So those would be then our missing pieces. The angle was 64.8 degrees, and then the two missing sides were the A and the B.